In this video, we are learning about key features of quadratic functions, and this is part 1 of part 2 of these key features. So a quadratic function, it forms this U shape when you graph it, and I'm going to show you why in just a second, but the parent function is y equals x squared. So anything is a quadratic when the highest exponent is a 2. Alright, so let's see why it forms this U shape. So if y is equal to x squared, I have some x values here, and if we plug those x values into the parent function's equation, we'll see what we get. So if y equals x squared, then y equals negative 2 squared. So if I plug in negative 2 and I evaluate that, then negative 2 times itself, which is negative 2 squared, is going to give us a positive 4. Okay, so if I plug in negative 1 times negative 1 is positive 1. If I plug in 0 times 0 is 0. Plugging in positive 1 times 1 is 1. And finally, if I plug in 2 times 2 is 4. So if I were to write these as points, this would be the point negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And if we plot these points, you can see them on the graph, and then connecting them, it makes this U-shaped pattern. Now the shape of that graph, that U shape, whether it's facing upwards or if it's flipped upside down, is called a parabola. So this is the parent function, y equals x squared. But sometimes you will see it written in standard form instead. It's still a quadratic because it still has x squared, but it has some other terms in the equation. So standard form is y equals ax squared plus bx plus c, where a, b, and c are any number. Alright, so now let's talk about the actual key features of a quadratic now that we know what a quadratic function is. Now, as we talk about the key features, I would highly encourage you to write these things down. So I have all the notes written out, and we're just going to talk through each key feature. So the first key feature that we'll talk about is whether the graph opens up or if the graph opens down. If the graph opens up, it would look like this, like a U facing upwards. And that happens when the a value, that's the number that's in front of the x squared term, if that a value is positive, meaning that it's greater than 0, so if that a value is positive, then the graph will open upward. And then we have an example here. So if you had this equation and you didn't have the graph to look at, you would look for the a value. Now our a value is 2, and that is a positive number, so that graph would open upward. On the other hand, if your a value is negative, so if a is less than 0, then your graph is going to open facing downward. So that would look like an upside down U or an N. Sometimes you would see it described as looking like an N. And we have an example here for that one. So if you have this equation and you can't look at the graph, you would look for the a value. So our a value here is actually a negative 1 because there's not a number written in front of that x squared. And since that is a negative, this graph would open downward. The next key feature is the axis of symmetry. For the axis of symmetry on the graph, The axis of symmetry is the invisible vertical line that splits the parabola in half. So if you look at this example down here, we have our parabola, and the axis of symmetry is that vertical line that splits it in half. That axis of symmetry also goes through the vertex, which is something we'll talk about next. But that low point that splits it in half, the axis of symmetry goes through that point. Now, if you don't have the graph to look at, there is an equation to find the axis of symmetry. So to find the axis of symmetry, you have to look at the A value and the B value and use this formula. So the axis of symmetry is x equals negative b over 2a. Because this is a vertical line, it's always going to be an x equals line. So let's look at this example together. If you have this equation and you want to know the axis of symmetry without looking at the graph, you would find A, which is 2, find B, which is 8, and plug those in to this equation. So our A value was 2 and B was 8. So that's where we are here. You plugged in A and B, and then just simplify. So negative 8 over 4 is equal to negative 2. So the axis of symmetry is x equals negative 2. That's the equation of that vertical line. Next, we are going to talk about the vertex, which we just mentioned with the axis of symmetry. So the vertex is either the highest point, which would be a maximum, or it's the lowest point, which would be a minimum. That's really easy to find if you have the graph, but if you don't have the graph, there is a way to find it with just the quadratic equation. So how to find the vertex of a quadratic without looking at the graph? If you have this equation as an example, and you wanted to know what is the vertex, well, you would start by finding the axis of symmetry because that gives you the x value of the vertex. So to find this axis of symmetry, which is the x value of the vertex, you would find A and B. So A is 3, B is 6, and we would plug those in here. So A was 3, B was 6. Right? So once you've plugged those in, you just simplify. So negative 1 times 6 is negative 6, and 2 times 3 is 6. So the axis of symmetry is negative 1, and that is the x value of the vertex. So the x value of the vertex is negative 1. Now we're going to plug in negative 1 into the quadratic to find y. So everywhere that there was an x up here, we're plugging in negative 1 in its spot. So we plugged in negative 1 here and negative 1 here. Now when we simplify, negative 1 squared means negative 1 times negative 1. And a negative times a negative is a positive 1. Then we have positive 6 times negative 1, which is negative 6, and then bring down the negative 2. Now we're just simplifying 3 times 1 minus 6 minus 2. So 3 times 1 is just 3. So 3 minus 6 is negative 3. And then subtract that 2 on the end to get negative 5. So y equals negative 5. That is the y value of the vertex. So we have x is negative 1. Whoops. We have x is negative 1, y is negative 5. So the vertex is negative 1, negative 5. Last but not least, this one is probably the simplest one, is the y-intercept or the initial value. So the y-intercept, or the initial value, is always the c value of the quadratic equation. So if you can't look at the graph to find the point where the line or the quadratic crosses the y-axis, you would just be able to look at the c value as long as it's written in this form. So the y-intercept 0, c, c came from the equation. That is the point where your line or your quadratic crosses the y-axis. So as an example, if you were given this equation, you would just need to locate your c value. In this case, it is -4. So the y-intercept is just 0, -4. So in this parabola, we have the graph, but we also have the equation. So from the graph, we can see that this opens upward, but it opens upward because our a value is what? Well, our a value, even though you don't see it, it's understood to be a 1 because it's the coefficient of a variable that doesn't have another number in front of it. So since a is 1, which is positive, this graph opens upward. Okay, now let's go ahead and identify our b value and our c value as well. So b is -2 and c is -8. All right, now let's look at our vertex. Well, since we know this graph opens up, we know that our vertex is going to be a minimum at what point? Well, it's that valley point. So that point is at 1, -9. Now the axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. So from the graph, we can see that that goes through the x value of 1. We can see that that x value of the vertex is 1, but we can also use this formula if we were not given the graph. So negative b over 2a means -2 over 2 times our a value. Well, negative of -2 is just a +2 over 2 times 1 is 2, and 2 over 2 is 1. So our axis of symmetry is x equals 1. And finally, our y-intercept. The y-intercept is just the point where the line or where the graph goes through the y-axis. Okay, well, since the c value is -8, even if we didn't have this graph, we could be able to tell that our y-intercept is going to be 0, -8. Okay, let's do one more. Again, let's go ahead and find our a, b, and c values. Our a is actually -1 because there is no number written in front, but there is that negative, so that's a -1. B this time is a +2, and c is a +3. Now this parabola, which way is it going to open based on the a value? So since a equals -1, it's going to open downward. That's because a is negative. Our vertex then is going to be what? Is it going to be a maximum or a minimum? Since it opens downward, it's going to be a maximum. And we can find that point on the graph. That is at the point 1, 4. Okay, our axis of symmetry. From the graph, we can see the vertical line that goes through the vertex is at x equals 1 again. But if we didn't have the graph and we just had to use the formula, it would be negative b over 2a. So negative b would be negative 2 over 2 times a is negative 1. So that would be negative 2 over negative 2, which is 1. And finally, our y-intercept. Well, our y-intercept is our c value, which is 3. So our y-intercept is 0, 3, even if you didn't have the graph. But we can see on the graph that it is at 0, 3. Now let's do a couple of examples where you don't have the graph given to you. So first, does this graph open up or down and why? Well, up or down is determined by the a value, and our a value is 3. So this graph would open up since it is a positive a value. Okay, now what is the axis of symmetry? So the axis of symmetry, remember that that is x equals negative b over 2a. So x equals, well, our b value, let's find those first, a and b. A is 3, b is 12. So if x equals negative b, that would be negative 12 over 2 times a, which is 3. All right, so negative 12 over 2 times 3 is 6. So negative 12 divided by negative 2. So our axis of symmetry is x equals negative 2. And that is the x value of the vertex. So the x value, since we already know that it's negative 2, then we can plug that in for x. So we have y equals 3x squared plus 12x minus 1. Now we simplify. So y equals 3, and negative 2 squared means negative 2 times negative 2, which is positive 4. Then we have 12 times negative 2, which is negative 24, and minus 1. Okay, so keep on simplifying. 3 times 4 is 12, minus 24, minus 1. I'm going to come up here. So y equals 12 minus 24 is negative 12, and negative 12 minus 1 is negative 13. So our vertex has an x value of negative 2 and a y value of negative 13. So that is the point negative 2, negative 13. Now, would this be a maximum or a minimum? Since our parabola opens upward, this vertex would be a minimum. Finally, what is the y-intercept? Okay, well, the y-intercept depends on c, and that's negative 1. So you could stop with just the y-intercept as negative 1, or you can write it as a point. The y-intercept is the point 0, negative 1. Right. Does this graph open up or down, and why? Well, that depends on your a value. And here, a is actually a negative 1, which is still a negative number, so the graph opens down. Okay, the axis of symmetry, remember that's x equals negative b over 2a. So we need to know a and b. A is negative 1, b is positive 10. So x equals negative b over 2a. So that's negative 10 over negative 2, and that is a positive 5. So x equals 5 is the axis of symmetry. So the x value of the vertex is 5. So now we're going to plug this in. So y equals, now we're going to plug in 5 to find the y value of the vertex. Right, now simplifying. So negative 1 times 5 squared is negative 1 times 25 plus 10 times 5 is 50, and then add that 7 on the end. So y equals, this is negative 25 plus 50 plus 7. Right, so negative 25 plus 50 is a positive 25, and then we have plus 7. So y is 32. Writing this as a point, that would be the point 532. Now, is this a minimum or a maximum? Since this graph opens down, meaning it would look like this vertex is a maximum. And finally, what is the y-intercept? So our y-intercept is c, which is positive 7. So the y-intercept is 0, 7.